ladies and gentlemen, we're going to move right along with Chapter 8. And so we're looking at Lesson 8.2. And we're taking a look at the angles and polygons. So our goal is going to be to find the measures of interior and exterior angles of polygons. The awesome thing about that is you just spent quite a bit of time in Chapter 6 finding the interior angles of quadrilaterals. So you already have a really solid foundation on what to do here. We're going to build upon that by meaning, since these are polygons, we could have any number of sides. So let's take a look at the 8.1 polygon interior angles theorem. What happens here is we've kind of done this investigation where we should see this. But if the polygon has n sides, and what this means is any number. All right, a polygon has to have at least 3 sides. So 3 sides, 4 sides, 5 sides, 6 sides. We can go up to 20 sides on our polygons. But if it has n sides, the formula for finding that is n minus 2 times 180 degrees. Now remember, we get that from the triangle. And so if we have 6 sides, it would be 6 minus 2 times 180. So this is going to be what it is for any convex polygon. Those concave ones have a little bit of a different rule. So in symbols, we would take the measure of angle 1 plus the measure of angle 2 plus 3 plus 4 plus 5 plus 6 up to whatever number you have, the final angle. This is the final angle, and it's going to equal that n minus 2 times 180 degrees. So, follow up. Let's do something with that. The triangle sum theorem states the sum of the measures of an angle of a triangle is 180 degrees. We've known that, I feel like, since day 1. So, use theorem 8.1 with a triangle. Substitute 3 for n because n is the number of sides. So, we're going to do 3 minus 2 times 180. 3 minus 2 is 1, and voila! 1 times 180 is the 180 degrees that we know we should be getting. Now we've done this with quadrilaterals. We said that in Chapter 6, the quadrilateral interior angles have a sum of 360 degrees. So let's use that theorem. Remember, a quadrilateral, quad is those 4 sides, so that means my n value is 4. So hopefully you're starting to see what we mean by n. So n minus 2 times 180 is our formula. 4 minus 2 times 180 is 2 times 180, which is that 360 degrees. And that test should be fresh enough in your memory that you recognize that. All right, so we've kind of proven this. And like we said, we saw this yesterday with our activity. So now we want to be able to use this. We want to find the sum of the measures of a convex. And once again, convex is important to remember here. Heptagon. Heptagon, you've got to know 7 sides. They give you a diagram, so you could go through and count 1, 2, 3, 4, 5, 6, 7, or just know the name. So that means we're going to substitute 7 for n. 7 minus 2 is 5, and 5 times 180, I kind of need to get my calculator out here, but we get 900. So the sum of the measures of a heptagon, convex heptagon, is 900 degrees. Now guys, it's one thing about memorizing a formula. It's another thing to draw that heptagon. Pick one vertex and draw in all of your diagonals. All right, I can't connect here because they're already connected with sides. Go through and count 1, 2, 3, 4, 5. There's your 5 triangles times 180 degrees in a triangle. That's where we get 900. So don't feel like you have to memorize this formula. You can visualize it if you're given the shape, or if you draw it yourself. All right, so the follow-up. Is your answer true for any heptagon? And I should say I need to be careful here. Convex heptagon, I keep jumping over that word. And the answer here is yes, ladies and gentlemen. As long as it's a convex heptagon, it will always be 900 degrees. So if you wanted to take the time and memorize everything that we went through in our activity yesterday, what we're going to have in our charts, you can, as every time I give you a heptagon, the sum of those interior angles is 900 degrees. All right. Now what we want to do is find the measure of one interior angle. So if we look at the diagram, the polygon has 1, 2, 3, 4, 5, 6 sides. So using that polygon angle theorem, we're going to substitute 6 for n. So 6 minus 2 is 4. And 4 times 180 is 720 degrees. So this is kind of like the problems you had in the quadrilateral chapter. I know I need to have a total of 720 degrees. I don't know what angle A is. That's the angle that's missing. But I know angle B, they told me, is 136 degrees. 136 again for C. We're down to 88 degrees for D. 142, 105. All right? But I know with all of these added together, they have to equal 720 degrees. Once you add those together, you find that you have 607 degrees. And so you're going to subtract that from 720. So when you subtract that from 720, you get the measure of angle A is 113 degrees. So ladies and gentlemen, I'm not necessarily showing you a new process. It's adding what you have and subtracting it from the total. What you need to be able to do is find this total angle measure. All right, so that's going to be what we're doing differently here in lesson 8.2. All right, now we're going to talk about the interior angles of a regular octagon or a regular polygon. In this case, it's an octagon. So an octagon has 8 sides. Notice we're setting you guys up with the same process. Think of your number of sides, substitute that number for n. So 8 minus 2 is 6, and 6 times 180 is 1,080, so 1080. Because the octagon they're giving you is regular, and it doesn't make a difference because this is an octagon, what it is this is the process for any regular polygon. Each angle will have the same measure. So I can find the measure of an angle in a regular polygon not knowing anything else. I take the 1,080 degrees and divide it by how many angles I have. When we take 1,080 and divide it by 8, I get 135 degrees. So the answer to our question is 135 degrees. How could I check that? Well, do 135 plus 135. Go through and add that up 8 times. And make sure you get the 1080. The other way we can do it is pick a vertex and draw in all your diagonals and count 1, 2, 3, 4, 5, 6 triangles. So guys, we're able to do this problem without really memorizing a formula, but we think of that process. 6 triangles times 180 degrees gives me my total. Take that total and divide it by how many angles I have. All right, now what we want to do is we want to be able to complete this chart here. Up a little bit. All right, so if I have a triangle, 3 sides, it's 180 degrees. 180 divided by 3 is 60 degrees. 4 is 360 degrees. Divided by 4 is 90, and we know a square had 90 degrees. We did a hexagon already, that was number 6. And so we're going to do 720. And when we divide that by 6, we get 120. We did a heptagon. And a heptagon has 900 degrees for the sum. And so when I do 900 divided by 7, I get 129. All right, so we're taking the sum and dividing it by n, the number of sides. We did an octagon together, and that was 1,080 degrees. And when we divide that by 8, we get 135 degrees. So your job right now is to find the sum for a 5-sided figure, find the sum for a 9-sided figure, and then find the number the measure of one interior angle. So you're going to do now, and we will check inglets. All right. Let's take a look at our checkpoint. I need to find the measure of angle G. Well, this is a 1, 2, 3, 4, 5-sided figure. So I know the sum for that on that 5-sided figure is 540. No, I can do that by doing 5 minus 2 times 180 is, I'm sorry, 540. I'm looking at the wrong chart. I don't have my calculator out. 540 degrees. Or we can simply go through and when we look at that, go back to our chart. I need to add all of these up, so I'm going to do angle G plus 111 plus 118 plus 130 plus 109. I feel like I'm running out of a little bit of room here. And set that equal to the 540. When I add those up and subtract, we get angle G is equal to 72 degrees. So I want you guys to use your chart and find angle G for numbers 2 and 3. If we take a look at number 4, it says find the angle the measure of an interior angle of a regular polygon. That means all the angles are congruent with 12 sides. So first I have to find the sum. So I have to know what the sum is. That's the number of sides minus 2 times 180. Well, 10 times 180 is 1,800. Now I need to find a single angle, and so that's the total, 1,800 degrees, and I divide that by the 12 angles that are in there. The number of angles and the number of sides are the same in our polygons, and so 1,800 divided by 12 is 150 degrees. You guys will be doing more of that in your homework. All right? So let's take a look at the exterior angles now. What we know about this, no matter what it is, as long as it's a convex polygon, the exterior angles add up to 360 degrees. So if I take this exterior angle, so notice we've had to extend a side. It's kind of going around in this clockwise manner. So if we take the exterior angle 1 plus exterior angle 2, add that all the way up to n sides, it's always going to equal 360 degrees. So how can we use this? They want us to find the value of x. Well, I know the exterior angles, I know all of those together equal 360 degrees. So 95 plus 85 plus 2x is 360. 95 plus 85 is 180 plus 3x equals 360. Subtract 180 from each side, so you get 3x is equal to 180, and so you divide each side by 3, and we get x is equal to 60. All right, so let's take a look at how we can check this. So we know that we have 95 plus 85 plus x plus 2x have to equal to 360. We said x was 60 degrees. So if we take 95 plus 85 plus 60, 2 times 60 is 120. So this was 180. We already knew that. 60 plus 120 is 180. And there's the 360 degrees that we want, so we know that it works. All right, we've got 2 checkpoints. I'll do one with you, and you guys need to do number 6 on your own. This is 90 plus 60 plus x plus 46 plus 73. We know that those angles together have to equal 360 degrees. So if I take 90 plus 60, so you're adding those together, plus 46 plus 73 is equal to 269 plus x is equal to 360. We subtract the 269 from each side. So if we do 360 minus 269, we get 91 degrees. So you guys need to do now, and we will check in class. All right? See you guys tomorrow.